In this video, we'll be covering the basic concepts of standard form functions. So in class, we identified that we had a number of different types of functions, one of them being the constant function, following up with that a linear function. After that, we then had a quadratic function, and then a cubic function. After that, I would go ahead and argue that we're going to have a square root function that is the inverse of the quadratic. Again, you can have the bottom half down here. You can have a cube root function, would look something like this. You could also have some quartic and some other unique functions. Some of those functions, again, revolve around having a rational function, which looks something like this. An exponential function looks something like this. A logarithmic function would look something like this, where there is very clearly an asymptote here, an asymptote here, an asymptote here, and an asymptote here. And then finally, we have our absolute value function. Okay. Now, on all of these graphs, there is a very special point that I am making known with these dots. Each of these points represent a special section on the graph that's going to designate how everything transitions in these the next section. So these being the standard graphs, I know that if this is a quadratic, it must look like y equal x squared to some extent. Now recall the standard form of this equation was ax minus h squared plus k. And then recall that every single one of these graphs had a very similar formula, in which case y is equal to a f of x minus h plus k, where the function changed depending on the graph that we had, this one being the square root, this one being the cube root, this one being the cubic, this one being a rational function, that one's going to be a relative tricky one, this one being an exponential function, so I'm going to make it a base e because that's one that's going to come up regularly later on, and this one being a logarithmic function, again base e for that logarithmic function. This one down here being the absolute value function. So you'll notice that on each one of these cases there is a different indicator of the type of function we're working with, and each indicator will simply replace this f. So for instance, if I look at y is equal to 3 times 1 over x plus 1 minus 2, it is very clear that this is what we would call a rational function because the function is this division by the variable. So that makes this right here, my h being negative 1, my k being negative 2, and my a value being 3. We could also have certain examples such as this, 2 absolute value of x plus 1 minus 3, where again, this is the absolute value function, again correlates to this. The graph should look something similar to this, where it is again multiplied by 2, that's my a value. My h is a minus 1, and my k is a negative 3. Now something you'll notice about the examples all three of these have in common. Number 1, the k on the outside, it does exactly what you think it's going to do, so the plus sign here will change as we go through. So if there was a plus sign here, then my k value would be a positive 2. However, inside the function, notice it's x minus h. So for me to get that formula, that setup, this right here would have to appear as x minus a negative 1. So my h is not necessarily a positive 1, but it is a negative 1 because of that plus sign changing the formula of what we had. And then our a value again remains constant all the way through. There can be other forms of a. For instance, you could have a fraction as that a value, and an assortment of other details. In the next video, we'll be covering exactly what these functions are going to look like based on what a does, h does, and k does.